Hello everyone, welcome back to another problem from the Blind 75 list of problems. And today we are solving group anagrams. In this problem, we are given an array of strings, strs, and we are supposed to group the anagrams in this array together and return an output array which has arrays in itself grouped together. So for example, we are given eat, tea, tan, ate, nat and bat. So the first set of anagrams which I can find are eat, tea, and ate, and tan and nat is the second set, and third set is bat. So we are also given that we can return the answer in any order. So let's return, for example, bat first. This is the first set of anagrams. The second set will be tan and nat. And similarly, we'll return a third subarray with eat, tea, and ate. So this will be our answer. We are also given that the number of strings in the input array is 10 raised to power 4. Let's call that n, and the max length in one single string is 100. So let's call that k. And we are also given that all strings consist of only lowercase English letters. So now the most straightforward approach we can think to solve this problem is to use a hash map where the keys will be of the form string and the values will be a string array which will store all the anagrams of a particular string as key value pairs. And what will be the key in this case? Can we just sort each of the strings whenever we encounter it and use that sorted string as the key and push that particular string in that sorted string key's value? It might sound a little confusing, but let's say we take this example, the first one, and we iterate through this array. So let's say we are given the first value eat. Now we sort this, so we get AET, and in the hash map we insert AET as the key and insert eat in an array as the value. Similarly, I move to the next word, which is T. I sort it. It will be also AT. AT is already present in the hash map, so I just append the current word in the same value. So I'll add T here. So let me just quickly add that. It was already there. I added T. Now moving on to the next word, tan. I take tan, sort this word, and I get ant, ANT. So ant is not already there in the keys of the hash map, so I insert ant along with the word which was tan. Similarly, moving on to the next word, 8, I sort this. What will I get? AET. 8 is already present, so I'll just append the current word here. So 8. Let me just add that real quick. 8. So eat, tea, and 8. Okay. Now move on to the next word, nat and bat. So similarly for nat and bat, what will happen is that nat will get added to this here, as nat's sorted string is also ant, and bat will form another key. So bat will be ABT, and I'll add bat here. Now once this hash map is formed, what I can do is go to this hash map and get all the values from this hash map directly and insert it into a new array and just return that array as the answer. So I take a new array, insert this array here, then this array, and then this array, and that will be the answer that I need. Remember that in a hash map in C++, which is also called as an ordered map, the values are not in sorted order, and we don't require them in sorted order because we are given that we can return the answer in any order. But there might be some extra processing if this would have not been given in the question and we needed to do so in some other order. Now, what would be the time complexity of this? So we are iterating through this array, so that would be n steps. Inside these n steps, what are we doing? We are first sorting the string, and the string length is k at max. So we are doing one operation of k log k inside this n. Then what we are doing, we are inserting it in the hash map, and the hash map will basically hash the string, so that would be O of k time. So let's say those are k steps for that. And what else we are doing? We are just appending it into the value of that key, so that would be also k, so that is discounted here. Okay, so now let's just sum this up and see what it gives. So it would be n k log k plus k, which would be nk log k. So let's just write it down. Let me use a red marker. O of nk log k. Okay, and what would be the space complexity for this? We are only using the hash map to store everything, so space complexity would be the number of strings into the length of the strings. So O of nk. Let me also write that with red. O of nk. So O of nk log k is the time complexity, and O of nk is the space complexity. Now, can we improve this approach to reduce the time complexity somehow? Let's see how we'll do that. Let's say we wanted to remove this log k thingy in a time complexity and make the time complexity only O of nk. What it means is that we want to avoid sorting the key for each input value. So is there any way we can do that? So if you think a little and try to find a solution for that particular problem, you'll realize that the key is not actually required for the answer. The key is only to get the buckets in which you are putting these values, and the buckets are based on the letters and the frequency of the letters. So what we can do instead of doing something like this is, for each string, for example, let me just retake this first example, eat t tan it, eat t tan it, what else, nat and bat. Okay, so was our first example. Now we only require the frequency and not essentially sorting the array, sorting each of the string whenever we are putting it into the hash map. So what we can do is create a dummy string, and which basically gives us an idea of what frequency of each letter in the string is. So for example, for eat, let's just say I store A1, E1 and T1, which is basically all the letters in the alphabet plus their frequency. So A1, E1, T1 is the first string, and I'm using this in the hash map. So let's say this is our hash map. Now any string with A, E, and T, all with frequency 1 in their string, will be pushed into this keys values. So 8, T, and 8 all come here. So similarly for the other strings, for tan and nat, it would be K1, N1, and T1. So tan and nat would come here. And similarly for bat, it would be A1, B1, and T1. This would be bat. Now, the main difference from this and the previous approach is that the difference in calculating the difference in the time for calculating this particular frequency string. So earlier when you had a string, for example, eat, and its length was k, you were taking O of k log k time to sort it. But what would be the frequency to create this string? The frequency, what would be the time complexity to create this string, the frequency string? So for this it was, I think, yeah, A1, E1, and T1 for this. So what you do is it go through the whole string, create an array of size 26, and similar to what we did in the previous anagram question, corresponding to each, assign a place, and just store frequencies in this array. So for AET, I would store 0, sorry, not 0, 1 in the first place, 0 for every other, and for E, whenever we reach E, let's say this is E, so 1 here, and somewhere there will be T, so that will be 1, rest all will be zeros. Now I go through this array, and wherever there is a non-zero frequency, I just use that corresponding letter with its frequency. So A1, B0, so ignore the zeros, and E is 1, so E1, and similar T is 1, so T1, and so this will be 26 steps. So this will be O of 26 time to iterate this array. So what would be the overall time complexity in this approach? Let's say time and space. Space would be the same because we are storing n strings with k length. So O of nk, because we are using the same hash map. And the time complexity in this case would be O of, we are using n strings, doing this 26 times. So 26, plus putting it in the hash map. So that would also be 26. And remember that we were adding a k here just for the comparison. So that would also be added here. And plus I think it should be k here. Let me just see. Yeah, so we are going through each string to calculate this frequency string. So that would be k steps. So I forgot about this. So this will be k plus 26 for this whole thing. And inserting it would be another 26. So we, as I told before, we need to do some kind of processing on this input string to create a hash for it. So that would be 26. Now let's just close it real quick. Yeah, so this would come out to be, on solving this, O of nk. But remember that there won't be a lot of difference in this and the previous solution, because nk and n log k, especially when you are given the k as small as 100. And remember that we are also reducing this down from 20, we are ignoring these 26 when we simplify it down. So nk log k and n of 26 plus k. So even if k is 100, so this would be 100 n plus log 100, and this would be 126n. So you can see there's not a lot of difference in these two values. So this would come out to be around 2 raised to power something, 3 point something. So this would be around 300 something n, and this would be 126n. But still there is not a lot of difference in these, and we'll solve this question by both the approaches in C++ and see how much time difference do we actually get in implementation. So let's do that. Okay, we are given a function group anagrams and a string of vectors strs. Let's try the first method which we discussed, which was by sorting the input strings and inserting it into the hash map. So first of all, let's create the hash map that we'll use. So it will be an ordered map of string comma vector of strings. So vector of strings, and let's name it m for now, and we'll iterate through the input strings for out to strs. Now what we want to do is insert this original string into this hash map, but first we want to get a sorted version of this str. So let's create a new str string sorted str, and name assign it equal to str, and then just sort this string sorted str dot begin sorted str dot end, and then just insert using the sorted str as the key. I just push back the original string. Got it. Now we have created the hash map using the sorted string, and now I want to get all the values in this in a resultant vector. So what I'll do is create this resultant vector, which will be a vector of vectors of string, call it res. And now I will go through each key value pair. So let's see, I forgot how do we exit. So let's say key value pairs in this map that we have created, and in the resultant vector I want to push back the values, and in the end I just return the resultant vector. This should work. Let's see if it does. Okay, all three cases working fine. Let's try submitting. Okay, so this worked in 29 milliseconds as expected. Now let's try the second solution which we discussed, which was not using this sorting thing and creating a new string of 26 size. So we'll keep most of the things same. I just need to change this sorting bit here. Let's create a vector to store the frequencies. So let's call it frequency and sw26 and initialize with 0 at every place. Now I'll have to iterate through this string. So auto character, let's call ch the character in this current string, and frequency of ch minus a I'll increase. Now I've stored these frequencies in this vector, but I want to have a string. So string, let's call it key string. Initially let it be empty, and now for all values in the frequency vector, so let's do something like this. In the key string, okay, let's if frequency of I is not equal to 0, only then I'll append it. So key string plus or keystring dot pushback, not use plus, because if we use plus in a string, that would be O of n operation, and the pushback is O of 1 when we push one character at a time. So we want to use that instead of plus equals to. This is very important, remember this. And I want to push back the current character, so that would be A plus I. So if you add I to A, it will result in the current character. So A plus say 25 would be 20, A plus 25 would be Z. So I'm pushing the current character and then I'll push the count. So how do I push the count? Okay, I'll create a new string and I can use the toString function to get the current count. So this toString function will convert the integer to the string. That would be frequency I, and this count can be 1 digit, 2 digit, we are not sure. So we have to iterate through this as well. So for auto count character and count, I will just push back. So keystring dot pushback count character. Instead of this we could also have done like keystring dot keystring plus equals to count, but that is again O of n operation, and this pushback is O of 1. So you want to avoid doing this. Instead of this, push one at a time, and then I want to keystring dot pushback A plus I, keystring dot pushback the counts. Okay, this works. Now I have the keystring, so I'll just use this keystring here. Did I name it keystring? Yes, the complete thing. And I'll push the current string. Now let's check if this works or not. I hope it does. Okay, this works as expected. Let's try submitting. Okay, that worked too. So see, now the the time taken for this code to execute is around 35 ms. So as we discussed earlier, O of nk and O of nk log k don't have much of a difference because the length is very small. Had this length been very high, the k would have been very high. So then we would have easily seen the difference. But as this is very comparable to 26, we don't see a lot of difference here. But just for the sake of it, we have discussed this solution. So that was all. Thank you for watching. Do like, share, and subscribe. See you in the next video. Happy coding.